So what we want to do in 3.3 is review some terminology that we talked about in class. So basically we have 4 definitions that we need to remember. We have a tautology, which means that the statement is true in every case. So when you do your truth table, the final column has nothing but truths in it if it's a tautology. We talked about a self-contradiction, which means that the statement is false in every case. So again, when you finish your truth table and you look at your final column, it should have nothing but false statements in it if it is a self-contradiction. Logically equivalent means that you have 2 truth value tables that have exactly the same results in every case. So if you look at the last column here and compare it to the last column here, so on the left you have TFTT, and on the right you have TFTT. So because it's exactly the same, these are logically equivalent. A truth table that is called a negation has exactly opposite truth values in every case. So for example, this one at the very end on the left, the last values are TFTT. And on the one on the right, the last values are exactly the opposites in every case. So FT, FF. That is a statement, 2 statements that are called negations. The other thing that we looked at in this section was the idea of a converse, an inverse, and a contrapositive. So just to review those definitions with you, remember that they're all based on an if-then statement. So they're based on a statement that looks like this. Okay, where it's P implies Q. Now, for the converse, all you do is you switch the P and the Q. So instead of P arrow Q, you do Q arrow P. Just switch the places of the P and the Q. For the inverse, you go back to the original statement, okay, which is here, and you negate both. So we'll have the negation of P implying the negation of Q. And for the contrapositive, you basically do a combination of both. You do the 2 negations, but you also switch the order. So we have not Q implying not P. Okay, so let's look at this in terms of an example. Our example says, if the timer is set correctly, the fries cook to perfection. And we want to start with the converse. So remember, the converse just means we switch the order. So now we say, if the fries cook to perfection, then the timer is set correctly. So just switching the P and the Q order gives us the converse. For the inverse, remember that we leave the P and the Q, we leave the order of the statements alone, but we negate both. So that's going to look like, if the timer is not set correctly, that's negating the first one, then the fries will not cook to perfection. That's negating the second one. And then finally, for the contrapositive, we switch the order of the original statement and we negate both. So we begin with, if the fries do not cook to perfection, and then we negate the other part as well. Then the timer is not set correctly. So again, that is a quick review of what we covered in section 3.3. You have plenty of other examples in your notes and in your homework. So if you need more help, that would be the first place I would suggest that you go. And again, you're welcome to email me if you have any questions about what is covered here.